brought to you by WikiVD Documentaries. Solar System.
The Solar System is the gravitationally bound system comprising the Sun and the objects that orbit it, either directly or indirectly. Of those objects that orbit the Sun directly, the largest 8 are the planets, with the remainder being significantly smaller objects, such as dwarf planets and small solar system bodies. Of the objects that orbit the Sun indirectly, the moons, 2 are larger than the smallest planet, Mercury.
The Solar System formed 4.6 billion years ago, from the gravitational collapse of a giant interstellar molecular cloud. The vast majority of the system's mass is in the Sun, with the majority of the remaining mass contained in Jupiter. The 4 smaller inner planets, Mercury, Venus, Earth and Mars, are terrestrial planets, being primarily composed of rock and metal. The 4 outer planets are giant planets, being substantially more massive than the terrestrials. The 2 largest, Jupiter and Saturn, petrels giants, being composed mainly of hydrogen and helium. The 2 outermost planets, Uranus and Neptune, are ice giants, being composed mostly of substances with relatively high melting points compared with hydrogen and helium, called volatiles, such as water, ammonia and methane.
All 8 planets have almost circular orbits that lie within a nearly flat disk called the ecliptic. The Solar System also contains smaller objects. The Asteroid Belt, which lies between the orbits of Mars and Jupiter, mostly contains objects composed, like the terrestrial planets, of rock and metal. Beyond Neptune's orbit lie the Kuiper Belt and scattered disk, which are populations of trans-Neptunian objects composed mostly of ices. And beyond them a newly discovered population of sednoids. Within these populations are several dozen, to possibly tens of thousands of objects large enough that they have been rounded by their own gravity. Such objects are categorized as dwarf planets. Identified dwarf planets include the asteroid series and the trans-Neptunian objects Pluto and Eris. In addition to these 2 regions, various other small body populations, including comets, centaurs and interplanetary dust clouds, freely travel between regions. 6 of the planets, at least 4 of the dwarf planets, and many of the smaller bodies are orbited by natural satellites, usually termed moons, after the Moon. Each of the outer planets is encircled by planetary rings of dust and other small objects. The solar wind, a stream of charged particles flowing outwards from the Sun, creates a bubble-like region in the interstellar medium known as the heliosphere. The heliopause is the point at which pressure from the solar wind is equal to the opposing pressure of the interstellar medium. It extends out to the edge of the scattered disk, the Oort cloud, which is thought to be the source for long-period comets, may also exist at a distance roughly 1,000 times further than the heliosphere. The Solar System is located in the Orion Arm, 26,000 light-years from the center of the Milky Way. Discovery and exploration. For most of history, humanity did not recognize or understand the concept of the Solar System. Most people up to the late Middle Ages Renaissance believed Earth to be stationary, at the center of the universe and categorically different from the divine or ethereal objects that moved through the sky. Although the Greek philosopher Aristarchus of Samos had speculated on a heliocentric reordering of the cosmos, Nicolaus Copernicus was the first to develop a mathematically predictive heliocentric system. In the 17th century, Galileo Galilei, Johannes Kepler, and Isaac Newton developed an understanding of physics that led to the gradual acceptance of the idea that Earth moves around the Sun, and that the planets are governed by the same physical laws that governed Earth. The invention of the telescope led to the discovery of further planets and moons. Improvements in the telescope and the use of unmanned spacecraft have enabled the investigation of geological phenomena, such as mountains, craters, seasonal meteorological phenomena, such as clouds, dust storms, and ice caps on the other planets. Structure and composition. The principal component of the Solar System is the Sun, a G2 main sequence star that contains 99.86% of the system's known mass, and dominates it gravitationally. The Sun's four largest orbiting bodies, the giant planets, account for 99% of the remaining mass, with Jupiter and Saturn together comprising more than 90%.
The remaining objects of the Solar System together comprise less than 0.002% of the Solar System's total mass. Most large objects in orbit around the Sun lie near the plane of Earth's orbit, known as the ecliptic. The planets are very close to the ecliptic, whereas comets and Kuiper belt objects are frequently at significantly greater angles to it. All the planets and most other objects orbit the Sun in the same direction that the Sun is rotating.
There are exceptions, such as Halley's Comet. The overall structure of the charted regions of the Solar System consists of the Sun, four relatively small inner planets surrounded by a belt of mostly rocky asteroids, and four giant planets surrounded by the Kuiper belt of mostly icy objects.
Astronomers sometimes informally divide this structure into separate regions. The inner Solar System includes the four terrestrial planets and the asteroid belt. The outer Solar System is beyond the asteroids, including the four giant planets. Since the discovery of the Kuiper belt, the outermost parts of the Solar System are considered a distinct region consisting of the objects beyond Neptune. Most of the planets in the Solar System have secondary systems of their own, being orbited by planetary objects called natural satellites, or moons, and, in the case of the four giant planets, by planetary rings, thin bands of tiny particles that orbit them in unison.
Most of the largest natural satellites are in synchronous rotation, with one face permanently turned toward their parent. Kepler's laws of planetary motion describe the orbits of objects about the Sun. Following Kepler's laws, each object travels along an ellipse with the Sun at one focus. Objects closer to the Sun travel more quickly, because they are more affected by the Sun's gravity. On an elliptical orbit, a body's distance from the Sun varies over the course of its year. A body's closest approach to the Sun is called its perihelion, whereas its most distant point from the Sun is called its aphelion. The orbits of the planets are nearly circular, but many comets, asteroids, and Kuiper belt objects follow highly elliptical orbits. The positions of the bodies in the Solar System can be predicted using numerical models. Although the Sun dominates the system by mass, it accounts for only about 2% of the angular momentum. The planets, dominated by Jupiter, account for most of the rest of the angular momentum due to the combination of the mass, orbit, and distance from the Sun, with a possibly significant contribution from comets. The Sun, which comprises nearly all the matter in the Solar System, is composed of roughly 98% hydrogen and helium. Jupiter and Saturn, which comprise nearly all the remaining matter, are also primarily composed of hydrogen and helium. A composition gradient exists in the Solar System, created by heat and light pressure from the Sun. Those objects closer to the Sun, which are more affected by heat and light pressure, are composed of elements with high melting points. Objects farther from the Sun are composed largely of materials with lower melting points. the boundary in the solar system beyond which those volatile substances could condense is known as the frost line, and it lies at roughly 5 astronomical units from the Sun. The objects of the inner solar system are composed mostly of rock, the collective name for compounds with high melting points, such as silicates, iron and nickel, that remain solid under almost all conditions in the protoplanetary nebula. Jupiter and Saturn are composed mainly of gases, the astronomical term for materials with extremely low melting points and high vapor pressure, such as hydrogen, helium, and neon, which were always in the gaseous phase in the nebula. Ices, like water, methane, ammonia, hydrogen sulfide, and carbon dioxide, have melting points up to a few hundred kelvins.
They can be found as ices, liquids, or gases in various places in the solar system, whereas in the nebula they were either in the solid or gaseous phase. Icy substances comprise the majority of the satellites of the giant planets, as well as most of Uranus and Neptune, and the numerous small objects that lie beyond Neptune's orbit. Together, gases and ices are referred to as volatiles. Thank you for watching. Brought to you by WikiVD Documentaries. Please like and subscribe below. Please like and subscribe below.